Hello GATE aspirants, welcome to part 7 of GATE solid state physics series. Question number 14. Consider a metal which obeys Sommerfeld model exactly if EF is the Fermi energy of the metal at T is equal to 0 Kelvin and RH is Hall coefficient. Which of the following statement is correct? Now RH is equal to 1 upon Ne and EF is equal to h cut square upon twice m into 3 pi square into n raised to 2 by 3. That means EF is proportional to n raised to 2 by 3 and that means n is proportional to EF raised to 3 by 2. So that means RH is proportional to EF raised to minus 3 by 2. So option number C is correct. Next question. A one-dimensional linear chain of atom containing two types of atoms of masses m1 and m2, where m2 is greater than m1, arranged alternately. The distance between successive atoms is the same. Assume that the harmonic approximation is valid at the first Balon zone boundary. Which of the following statement is correct? Now it is a one-dimensional linear chain of atoms, so it is diatomic. So for that, if we plot this versus k, then this will be 0. First Balon's boundary will be at plus minus pi by a. So this branch will be optical branch and this branch will be acoustical branch. And this corresponds to, this point corresponds to omega 1, which is equal to under root 2 beta by m2. This is equal to omega 2, which is equal to under root 2 beta by m1. And this corresponds to omega 3, which is under root 2 beta upon 1 by m1 plus 1 by m2. Here m2 is greater than m1. Now option A, the atoms of mass m2 are at rest in the optical mode while they vibrate in acoustical mode. See, this is optical mode, and in optical case only mass m1 is vibrating, and in acoustic mode only mass m2 is vibrating. So A is correct. Option B, the atoms of mass m1 are at rest in optical mode while they vibrate in acoustical mode. So this is not correct. Next, both types of atoms vibrate with equal amplitudes in the optical as well as acoustical modes. This is not the case because here m1 is vibrating, here m2 is vibrating. Both types of atoms but with unequal non-zero amplitudes in the optical as well as acoustical modes. Now the lighter mass will be having greater amplitude and the heavier mass will have lesser amplitude. So this is also not true. So option A is correct. Next question. A solid material is found to have a temperature independent magnetic susceptibility chi equal to C. Which one of the following statement is correct? Now chi is equal to mu r minus 1, which is equal to mu by mu naught minus 1. Now chi is negative for diamagnetic materials. Chi is positive for paramagnetic and ferromagnetic. Now for paramagnetic material, value will be less than 1, much smaller than 1, and for ferromagnetic it will be a large value, but it will be positive for para and ferromagnetic material. And gamma is equal to minus 1 for superconductor. Now if C is positive, the material is para or ferro. If C is positive, that it can be paramagnetic material as well. So option B is also not correct. Option C, if C is negative, the material could be type 1 superconductor. So that is correct. So here option C is correct. Next question. Atoms which can be assumed to be hard spheres of radius r are arranged in FCC lattice with lattice constant A such that each atom touches its nearest neighbors. Take center of one of the atoms as origin. Another atom of radius small r assumed to be hard sphere is to be accommodated at a position 0 a by 2 0 without disturbing the lattice. The maximum value of r by r is. Now consider a FCC structure, and at the center of it, there will be one atom, and on the corners as well there will be atoms, and they will be touching each other. So at 4 corners we'll have 4 atoms. So this is the case, and the radius is capital R, and the lattice constant, this is equal to A, and in between this we have to put one more atom whose radius is smaller, so this will be 2R. So that gives us A is equal to 2R plus 2R. Now consider this diagonal path. Along this diagonal path, this will be 4 times radius, 1, 2, 3, 4. So 4 times radius, and that will be equal to, if this part is A and this is also A, then diagonal will be root 2A. That means A is equal to 4R by root 2, or it will be 2 root 2 into R. So we can substitute this here. This will be 2 root 2R is equal to 2R plus R. 2R. Dividing throughout by 2. So this will be root 2R is equal to R plus R. That means root 2 minus 1 into R will be smaller. And root 2 is 1.414 minus 1, that will be 0.414. And that will be equal to small r by capital R. So the maximum value of R is up to 2 decimal places, it will be 0.41. For this question, answer range was 0.40 to 0.42. Next question. The energy versus wave vector relationship near the bottom of a band for a solid can be approximated as this, with lattice constant and A, B values are given. At the bottom of the conduction band, the ratio of the effective mass of the electron to the mass of free electron is. Now Ek is equal to A, that will be K square A square plus B K raised to 4 A raised to 4. So dE by dK will be K square, that is 2K. So this will be 2A K A square plus 4B K cube A raised to 4. Second derivative will be dE square by dK square, and that will be 2A A square plus 4 into 3, that will be 12B K square into A raised to 4. Now at the boundary of first Pilon zone, no, at the bottom of conduction band, okay, at the bottom of conduction band, this K will be 0. So if we put K is equal to 0, then d2E by dK square at K equal to 0, it will be simply 2A A square. And effective mass Me star is equal to h cross square by d2E by dK square. And that will be h cross square upon 2A A square. That will be the effective mass. And the ratio of effective mass to mass of free electron, that will be Me star upon Me, and it will be h cut square, value of h cut square is given 1.05 into 10 to the power minus 34 the whole square. 2 into A is given 6.3 into 10 to the power minus 19 into A is given, A is 2.1 angstrom square, and divided by mass of electron, is also given. So this will be equal to, after substituting and calculating these values, this ratio comes out to be 0.218, which is nearly equal to 0.22. So that will be the answer. And the answer range for this question was 0.20 to 0.24. Next question. The Fermi energies of two metals X and Y are 5 electron volt and 7 electron volt, and their debye temperatures are 170 Kelvin and 340 Kelvin. The molar specific heats of these metals at constant volume at low temperature can be written as Cv of X is gamma xt plus axt cube, Cvy is gamma yt plus ayt cube, where gamma and y are constant, assuming that the thermal effective mass of electron in the two metals are same, which of the following is correct? Now here Cp is equal to gamma T plus AT cube, where gamma is 3 by 2 n kb square into 1 by EF. That means this gamma is inversely proportional to EF. And A is equal to 12 by pi raised to 4 upon 5 into n kb upon theta d cube. That means A is proportional to 1 upon theta d cube. So gamma x upon gamma y will be equal to Ey upon Ex. That will be 7 electron volt upon 5 electron volt, which is equal to 7 by 5. And Ax by Ay will be equal to theta d y cube upon theta d x cube, and that will be equal to 340 upon 170 the whole cube. That will be equal to 2's cube, which is 8. So the answer will be 7 by 5 and 8. So option A is correct. So these were all the questions from GATE 2016 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.